All right, so in this video, we're just going to chat a little bit more about this really general idea of congruence and hopefully shed a little bit of light in kind of really what's going on behind the scenes. So in this case, we're going to be looking at a couple of examples that I often refer to as clock arithmetic. And that is we're going to be looking at some examples in this modulo 24 setting as well as mod 12. So the idea of 24 is going to occur in this question of kind of how many days are there in a given set of hours, because we know that there are 24 hours per day. So every time I break off one of these groups of 24, I'm really just breaking off a day. Likewise, we have 12 occurring all over the place. You kind of have nice 12-hour blocks when you look at a clock. We have 12 months in a year, so 12s often occur all over the place as well. So this first question is going to be, I'm going to be handed this number 73. And I want to start to think about what is 73 going to be congruent to in this modulo 24 setting. So in this case, this is exactly that question that I alluded to already. The idea is that if somebody tells me, how many days is 73 hours? Well, there's a couple different ways you could do this. One of which is you could take the 73 and you could divide it by 24. In this case, I'm going to see how many full days there are. So in this case, if I try to do this division, so 73 divided by a 24, I know the 24 goes into 73 three times because 3 times 24 is actually going to be a 72. And then at the end of the day, I'm going to have a remainder of 1. So in this case, it is not a perfect number. In this case, it's going to be 3 full days and 1 extra hour. So if I write this out in this kind of formal math setting, it's going to be, well, here's my 73. Then there's this question of how many chunks of 24 did I break off? And I broke off 3 of these things, but I still had 1 extra hour remaining. So that's really kind of another way that you could attack this thing as well. If you gave me the number 73, what I could do is I could just start subtracting 24 hours from this thing. So initially I have 73 hours. If I subtract a full day, that is subtract 24 from that thing, what I'm going to be left with is then 49. So in this case, I know that 73 is going to be 1 full day plus 49 extra hours. And you could keep on going after that. So if I'm at 49, I could then subtract off another 24 to bring me down to 25. And then I could take that 25 and I could subtract off another 24, leaving me down at a level of 1. And if you think about it, that's exactly what you do when you do division. In this case, you probably don't remember when you first learned how to do division. You just remember the kind of algorithm of how division works. But really all division is just this kind of repeated subtraction that occurs over and over and over again. So in this case, when you look at the number 73 and you divide it by 24, what you're asking is how many times can you remove a 24 from this number 73? So in this case, I can take 73 and I can subtract off 24 3 times. So 73 to 49 to 25 to 1. And then I'm going to have that little 1 left over, and that's exactly what my remainder is. So in this world of kind of congruent stuff, that can actually become very useful when we start looking at a bunch of things that are all going to be congruent to each other. So we've kind of alluded to this already, but if I was given the number 49, I could also see that this is going to be 1 mod 24. And if I wanted to write out the kind of formal statement, I'm going to have a 49, which is then going to be a 24 times a 2 plus a 1. Likewise, I could look at this 25, and I know that this is going to be a 1 modulo 24, because I know that 25 is going to be a 24 times a 1 plus a 1, and we know that a 1 is going to be congruent to 1 as well. So what can actually end up happening in this case is you form this really nice set of things that are all going to be congruent to each other in this mod 24 setting. Moreover, all of these things are also going to be congruent to 1. And that's really where I kind of want to go into. I really want to start thinking about where is this kind of the smallest positive number that I can get in this congruence world. I could always say that 73 is congruent to 49 mod 24, but that's not as useful as saying it's actually going to go all the way down to, in a sense, its root. And that's really what this number 1 is going to be viewed as, is that's going to, in a sense, encapsulate all of this information of this entire congruence class. So if I start to build up this set of all of these things that are going to be congruent to 1 mod 24, I could actually start with this idea of 1, because 1 is congruent to 1, and I'm good to go from there. And then I can go to the next number, which in this case is going to be the number 25. I could go to the next number, which would be the number 49. I could go to the next number, which would be 73, and I could keep on going from there. The way that I'm getting to the next number is by simply just adding 24. So if you hadn't really thought of that in this congruent setting, it's a very nice little trick. It's this idea that if you want to start forming a large set of things that are all going to be congruent to each other, all you have to do is just start adding or subtracting that modulus that you're dealt. So in this case, I started with 1 and I added 24 as I went. Well, I could also subtract. So in this case, if I go from 1 downward, so in this case, if I subtract 24, well, I'm going to be down at a level of negative 23. And the idea is that, well, I could also get back to that 1 by simply adding 24. So in this case, this giant set goes both directions. There's going to be this infinite number of things that are all going to be congruent to 1 mod 24. And later in this course, we're actually going to refer to these things as a congruence class. But for right now, it's just going to be this kind of general notion of what is this kind of idea of being same. In this case, I want to start thinking of things that are going to be the same in this mod 24 setting. So if I want to practice this idea a little bit, I can actually just start with a kind of new number. So in this case, if you were handing me the number negative 13, if I want to think about what is negative 13 going to be congruent to modulo 24, well, if you wanted to kind of go through the long division process and things like that, you can. Or what you could do is you could simply take negative 13 and add 24 to it. So in this case, if you add 24 to negative 13, it's going to jump up to a positive 11. So in this case, I know that negative 13 is actually going to be a positive 11 mod 24. There's this kind of giant span of 24 between the two, starting at negative 13 up to 11.